Yeah, so implicitly, we discussed gradient descent in our last class, and it is an optimization strategy that helps to minimize the network's error. Yeah, so it's an optimizer that helps you to what to achieve, for example, a global minimum. Yeah, so it moves gradually, adjusts the weight such that once it gets to this bottom, and then remember what we mentioned earlier, at this bottom, dE over dE over dW7 is 0. Yeah, so that's the function of gradient descent. So it moves, for example, from the top here, from a big error, and gradually the system, the optimizer here, gradient descent, tries to what? To move down until it gets to this global minimum. Yeah, so that's a function of gradient descent. And in this class, we'll use, in this session, we'll use it to calculate how much to adjust our weight. Yeah, so if you remember, we derived this formula in our last class, where E is what? T, that is target minus output. And remember, we had 0.44. So this is actually 0.44. I remember we talked about a sigmoid. We talked about S. So S encapsulates the output, which is 0.56. Remember, we talked about S, and then S is actually 0.52 times W7, which is 0.1, and then 0.4, then sorry, 0.52 times, I think, 1, if I'm right. And then we also have 0.526 times the weight W9, and then all of that goes into sigmoid, and then it gives 0.54. So this is actually 0.54. Yeah, so it actually gave, so it should be 0.56 here, not 0.54. The output should be 0.56. So that's my mistake, 0.56 here. And that's the output here. And the formula also says 1 minus that output, and that gives 0.2464. Yeah, and then if you now combine minus this error, which is 0.44 times all of this, so all of this gives minus 0.1084. And then remember, we also have this one here. So our 03, 04, 05, which is this one. Output from N3, output from N4, output from N5. You collect that into a 1 by 3 matrix. Then you do the matrix multiplication, which is here. So it becomes this times this, and that gives so how much you need to adjust W7, you can see. So you have to adjust it by minus 0.0564, and then this times this will tell you how much you need to adjust W8 such that the error is reduced. And then you also have this this times that, if you can see now, you need to adjust the. So here comes another concept. Here it says learning rates. So the learning rate is a small multiplier that prevents the network from making updates that are too large. So it ensures the nudge, the adjustment is controlled and stable. And then, so imagine there are times that, so instead of having this one now, you might have a very big update. So instead of having 0.056, it might be something like this, maybe a jump of maybe 2.5, or it could be 0, let's say 2, or whatever it is. So instead of having this jump, you have 2. And let's imagine we come here now, and you can see now from 0.1, and then you have a large jump of 2. So that's a very, very large jump. And because of that, we need to multiply that update by a small value. So it could be 0.1. I think in sometimes you have, I mean, you read in papers, they usually use maybe 0.001, but here now we're going to use 0.1. So it's a small value that you will use to multiply this. I mean, such that I mean the update is it's not too big, yeah. Because imagine if we have from here now, if you have an update that moves from this point to this point, you can see we have missed this point here now. So it moves from here, then it jumps the global minimum, then it moves here. So it begins to increase, and that's a problem. So that's why we need to to adjust or to regulate the updates. So it moves gradually until it gets to that global minimum. And at this point, at this point here, we'll record the least error, and then the training process terminates. And so that's the essence of our learning rate. And so we have this formula here now. You can see the old weights. So for W7, our old weight is what? 0.1 minus, remember, so you're actually subtracting this. You want to adjust the old weight with the new updates, and then you have to multiply by our learning rate. So that becomes our old value minus our learning rate, which is 0.1 times. Remember, this actually had a negative output here, the adjustment, and so you have it here. So negative actually means that you have a negative adjustment. It means that the update is going from left to right. Then if you have a positive update, it means that it is going from right to left. So here we have a negative one. So that's our what? That is our update. So using this formula to get the new weights, because we need to get the new weight, and the new weight to be used for the forward pass, the next iteration, training iteration. So we have our new weight. So our new weight becomes what? Yeah, so our new weight, so new weight 4.7. So this should be this one. New weight for this. So that's a new weight, and then new weight here. So you can see the new weight for W7 is the old weights minus our learning rates times the updates on W7. And then you can see now minus goes with minus, so it becomes 0.1 plus whatever you have here. And then so you can see now that's the new update now. So the old update was 0.1. Then look at the new update now, 0.105. And then if you come here and then we trace maybe 0.105, you can see the error has actually reduced from 0.44 to 0.35. And the next class we'll also do for this phase, for the weight here. Yeah, so we'll stop here and see you in the next class.